All right, guys. Well, I hope you're having a good break here, break from being at school. But now this is our first day of e-learning. I hope you're healthy. I hope you're safe, and not too bored out of your minds, but just bored enough that you're actually looking forward to doing some math. Guys, when we're starting this adventure together, this e-learning thing is new for everybody. Please do not stress out to the point where you just rage quit and smash your Chromebook against a wall. All right. Um, it's going to be frustrating. You're going to struggle. You're going to make mistakes. You're going to fail at times. The important thing is that we're jungle tigers and we get back on that bike and, get back up on that horse, and any other analogy I can come up with at this point, right? But that we try again, learn from mistakes. And the biggest thing is we communicate. I'm communicating with you. I've set up lots of different channels to communicate with you. I need you to make sure you're using that back at me. During a normal school day, from kind of 7:30 to 3 on a normal scale school day, I will try and regularly be cycling through all of the responses I'm getting through Schoology, through email, through ClassKick, and trying to get back to you as quickly as possible. I have some real life distractions on my own called children, Izzy and Addie. Maybe they can make an appearance in a video, especially for my 8th period class. They might be able to say hi at some point. But guys, just stay with it. All right, we'll get there. We'll figure this out. This is unprecedented times. This has never happened before in the history of education. Because even when there was maybe some sort of pandemic like this before, which honestly I can't think of, they didn't have the technology to do e-learning. So literally, you are the first students in the history of the world to have to learn under these circumstances in this way. All right, so that's kind of cool when you think about it. I know it's a little scary, but it's also kind of cool that you'll be able to, when you're like 80 or 90, talking to your grandkids, to be like, remember back in the day when e-learning was a new thing, right? Maybe you won't talk like that. I don't know, but that seems like what grandpas talk like on the cartoons. So, all right, let's dig in here. We're talking about quadratic functions. This whole unit 7 is about quadratic functions. So what is a quadratic function? Well, quadratic function is a specific type of essentially equation, right? We see that here. This expression here, our quadratic expression or quadratic polynomial, right? That we worked with in Unit 6 a lot here. X squared plus bx plus c was an expression, but now notice we've set it equal to another variable, f of x, or what does fx say? That's right. You definitely remember y. When we do that, we get an equation, which is a quadratic equation. And an equation is one way to represent a function. So that's what we're dealing with here. We're going to work with these a lot of the same way we work with linear functions. We're going to graph them. We're going to substitute values and simplify and solve. We're going to look at tables of values. We're going to do a lot of different things with the different representations of quadratic functions. In these notes, what we're going to be focusing on is this type of equation, because there's going to be, just like in linear functions, there were different types of equations: slope, intercept form, point slope form, horizontal, vertical, standard form, right? This type of equation here is called the general form of a quadratic function. General form, kind of like slope, intercept form, general form. All right, and it will always follow this pattern. We'll see our quadratic expression, our quadratic trinomial here, equal to f of x or y. All right, now what we're going to go into in these notes is we're going to talk some vocabulary. We're just going to finish this first page. We're breaking these notes into 4 different sections, so we're not going to try and bite off a ton in each video. Right, but we're gonna break this up into vocabulary, and then also, guys, we're gonna be talking about a calculator. So pause the video and go get your calculator if you don't already have it with you here. All right, so let's go back to the notes here. So as we discussed, these graphs are going to look a little different than a linear function, right? This here, these are 3 examples of what the graphs of a quadratic function look like. They're kind of this curvy looking thing, right? This curvy thing, and sometimes the curvy thing can open down, meaning we have kind of like a mountaintop, or it can open up, meaning we have like a valley. Now, if you look at these curves, probably you can think of things in real life that kind of use something curved like this to either design in architecture or building. You can see that this models the path when something is thrown. It goes up into the air, hits a highest point, and comes down. You can see this might be 1/2 of the McDonald's golden arches, right? We wouldn't have McDonald's without quadratics, right? And this shape, this curvy thing, has a specific name, and it is called a parabola. It's a funny name. I didn't make it up. I don't know who did, but we're stuck with it. So when you see a curve that looks like this, or you're talking about the graph of a quadratic function, an equation, that is called a parabola. All right. So every point on the graph of a quadratic function, the parabola, is a solution of the function. Remember, a solution is just something that is going to make the function, yep, you remembered it, true, right? So if I plug in the ordered pair, any ordered pair on this curve here, so I pick this point or this point or this point or this point, plug it into the quadratic function, the equation, it will make that equation true, right? Now, some of these points, though, some of these solutions are kind of more important than others. So let's talk about some of these. First is the vertex. This one's huge. This is like the granddaddy of them all. This is the most important point that you will need to be able to know, find, all that good stuff with. The vertex is either the maximum, right? That's the mountaintop. So we can kind of write mountaintop, right? Or the minimum, and this is the bottom of a valley. So valley bottom here, right? Of the graph. And essentially what we're basing that on is its range value, its y value, its f of x value. A mountaintop is going to have the absolute highest y value, where a minimum, a valley, is going to have the lowest. All right, now this is also where we talk about kind of rate of change switching. In a linear equation, rate of change never changed, but that's different now. So rate of change is going to change from negative, oops, let me try that again, negative to positive or vice versa. Just really quickly, take a look over here at this graph with me. Notice, if I kind of follow from left to right, this parabola, notice I'm going up. I have a positive rate of change. But as soon as I hit this vertex up here, notice again, going from left to right, now I'm going down. I have a negative rate of change. And here, same deal. Left to right, I'm going down, negative rate of change, hit the vertex, and now I'm going up. All right, that's not going to be super important right now, but that idea of rates of change changing is going to be really important as we go further into math there. Timer, go away. All right, so that's the vertex, though. Hopefully, visually, it's pretty easy to find. We're going to find it not only graphically, but also on a table of values. We're going to look for patterns, and we're also going to find it algebraically from equations. All right, y-intercept, the good old-fashioned y-intercept. Same thing it was in x-intercept, same thing it was back when we were dealing with linear functions. The y-intercept is a solution, an ordered pair, where the x-coordinate or domain value, x-coordinate domain is 0. All right, the x-intercept is just the opposite. It's where the y-coordinate or range is 0, right? An x-intercept is always going to be some number, comma 0. Oops, sorry, I got that in the wrong line. Move that down here. X-intercept, I said the right thing, I just wrote it in the wrong place. And a y-intercept is always going to be 0, some number. All right, that's something we learned back in Unit 3 with our linear functions. Now, introducing a new word here. 0. Well, it's not a new word, but it's a new meaning of the word. Normally, we think of the number 0 when we use the word 0. When we are talking about the 0 of a quadratic function, what we're asking for is actually a number, which might be 0, but most likely is not 0, but a domain value, a number which, when we put it into the equation, causes the range value f of x or y, will result in that being 0. Essentially, what's a value of x that will make y equal 0? That's how we can kind of summarize this. What number for x will make y equal 0? That's essentially what summarizing that kind of fancy sentence there. Now, the good news is, though, if you found the x-intercept, you actually already found the 0, because look at the ordered pair here. Essentially, what is this? This is an x coordinate, right? An x value when the y value is 0. So the good news, guys, is if you found an x-intercept, you also found the 0, because the 0 is the x coordinate of the x-intercept. All right, now, along with these 4 vocabulary words above, which are all ordered pairs or coordinates of ordered pairs, right, we are still going to have to come back here and be able to identify domain and range. Now, domain and range, we're not overly tricky with linear functions. They get a little bit more dicey when we get to quadratic functions. It's not horrible, but it's going to require it's a little more complex. It's going to require a little bit more thought and kind of problem solving here. Let's just define these two, and we're going to get review of interval notation and actually working with these graphs in our next video here. So we're going to define these, and then we're going to go to the calculator. So the domain are the input values of a function. Input values essentially are another word for independent values. We've used that word a lot, independent, right? Essentially, the number that gets to be whatever it wants to be. And in most of our functions, and the way we're going to write them, the domain values are the x coordinates, the x values, the x variable of our function. All right. Range are the output values. These are generally thought of in our formulas as the dependent values. So this is a number that doesn't get to choose what it wants, but it's going to be something based on what we put in for the domain. And in our situation, guys, we can think of the range again a lot of for everything we're going to work with as the y coordinates. All right, so hopefully all this vocabulary made sense. If any of this vocabulary didn't make sense, please hit me up on email, hit me up on Schoology, and we can try and answer your questions further. All right, let's now move to the calculator. So we've talked about quadratic function, we've talked about the equations, right? Let's talk about using our calculator a little bit to work with the first worksheet. So this is, we're assigning this today. And this is the first worksheet here. So all we're going to ask you to do is, if we give you an equation, a quadratic function that's an equation, can you fill in the tables given the domain values, given the x coordinates, and then graph those 5 points to then be able to draw a smooth curve for the entire parabola. All right, and it's really easy if you know how to use your calculator. So first of all, we want to go to f of x equals y equals here. And the first thing we've got to be able to do is to put x squared minus 2x minus 3 in our calculator. Now remember, our variable button is this one right here, x. So it's going to be x squared, use the squared button here, minus, not negative, 2x minus 3. All right, so you can just put that in there. The equal sign is highlighted, meaning that we are graphing it. Make sure none of your plots are highlighted. Make sure those are all unhighlighted. And also make sure you don't have anything else in the y equals that you don't actually want to graph. So if we were going to graph this, what we would go to zoom, and then we would want to choose zoom standard would be the first one to choose. So zoom 6, and you can see we're going to get a graph right here. Now, just looking at the graph, though, it's really hard to identify ordered pairs for a table looking at a graph. So what you can see here is this handy dandy section called the table right here. All right. Now, before we go to the table, though, let's make sure our table is set up correctly. So second window gets you to the table set option here. So currently our table is going to start at 0. This triangle here is telling you how it's going to change each time as 1. And for right now, we want these both to be auto. Don't worry about the ask. We'll talk about that maybe sometime later when it's useful. But right now, let's just leave it on auto. So once we make sure our table is set up okay, we're going to go to hit second graph, which gets us to our table. All right. And now what you have here is a list of x and domain values, which are automatic. Notice we cannot change those. And then y values that we get from those. So if we go to our worksheet here, we want to look at the ordered pairs starting with -1 going to 3. So starting at -1, so I'm going to scroll up on the x. So here's my ordered pairs. -1 to 3 for the x coordinates gives me 0, -3, -4, -3, 0 for the y coordinates. So let me come back here with my handy dandy stylus, which you all have, and I'm going to put in 0, -3, -4, -3, 0. Now, if you don't have a calculator, what you can always do, if you know the x coordinates to find the y coordinates, is plug it in. So I'm just going to do one of them here for you, just to show you. So if you don't have a calculator, you can always just choose to plug in -1 for x. So f of -1, substituting -1 for x, would give me -1 squared minus 2 times -1 minus 3. Well, -1 squared is 1. -2 times -1 is +2 minus 3. 1 plus 2 is 3. And 3 minus 3 is 0. So f of -1, when x is -1, y is 0. That's the ordered pair I just got there. All right, again, you can do it by hand, kind of working it out here, but I think using the table in your calculator is a lot faster. So now let's actually graph these points here. So I'm going to go to -1, 0. I'm going to go to 0, -3. I'm going to go, oops, I'm sorry. My bad. All right, -1, 0. 0, -3, 1, -4, -2, 0, and 3, 0 there. You should get a smooth looking curve when you kind of connect these points. And then just continue that parabola going up. All right. So I just did number 1 for you. I believe there's 6 on this worksheet that I want you to give a shot to. Again, I would highly recommend using your calculator for these tables. To fill in, if we give you the domain values, fill in the range values, and then practice graphing it. So your job on the first day is fill in the vocab, practice using your calculators to graph the quadratic, to not graph yet, but to get the table of values to then graph your quadratic function. All right. I know this first one was a little bit longer. There was more talking because it was vocabulary and we're doing the introduction, but the videos going forward, we'll try and keep them, a little bit shorter, splitting all of this up. So again, welcome to e-learning, both for myself and for you, and I'll see you in the next video.